Good afternoon, everyone. This is Ankur Safre. Which religious conversation is? I think.
Yes, Ankur. It's good.
PPT visible service?
Yes, it is visible, Ankur.
Yeah. So, good afternoon, everyone. My name is Ankur Safre, and today I'm just um, taking a problem solving session for Introduction to Photonics, live session one. And the course instructor is Professor Balaji Innovation, Electrical Engineering Department from IT Madras. So let's just start. So first I will just ask some doubts. If you have anything, you can ask, sir. Then we'll move toward our assignment, the first assignment. So if it is not possible to solve by me, so I'll just tomorrow also we have a live session. So we'll discuss tomorrow also. I'll just look into it and I'll clarify your doubts. Is it okay? Thank you.
Yes, yes, sir. Yes, Ankur.
Yeah. So do you have any uh, doubt regarding the extra thing or assignment related changes? You will go further guys.
Um, Sir, I was facing problem regarding the fiber brag grating.
Is it
How does how
uh, related to week one or any other week problem?
week 2 it was end of week 2, sir.
Okay, actually I can't solve now week two problems because as per the NPTEL instructions, this is live now, these two assignments. So if you have any problem, then just let me know. I will just come in tomorrow because tomorrow I can solve that problem. So
Okay,
just
so this session is meant for discussion of week 1
yeah,
assignment,
this
sir.
is for week one, and this one week two will
Okay,
be
okay.
tomorrow. Yes.
Okay, okay.
If
One
you
second,
have
sir.
doubt,
I'll
you
go
can just
through
type.
my week
I'll go through that
questions if
and
I
just
have. Week 1 mostly I will not have it.
okay. So whatever you have doubts regarding this week, you can just type. I'll just see.
Okay, sir. Okay.
This this is regarding week one only. So yeah, you can type and just see. You can do. Yeah. Good evening, everyone. Whatever doubts you have, just type. So I will look one by one in that. You can ask also. Only you can ask. Yes. Yes. Okay. So should I solve these one assignments? So if you have any question, you can ask in write an application. Yes, sir. So the question number one is, okay, yeah, the question number one is like, for you the slide is visible. Question number one is visible. Hallelujah.
Yes, sir.
Yes, sir. Visible, sir.
Yeah. So here, the question is like which of the following characterize the real nature of life. So you have to tell about this. Can I ask one question? Did you completed this assignment? Week one assignment?
Yes,
Is
sir.
it completed? Like anyone having doubt? Anirudh, Prabhapati ji?
I don't think it's calculated yet.
I didn't get you. Like, can you repeat again?
Yes, sir, I don't think it's calculated yet.
Okay. So now week three session also live. I think this week three assignment also live now. So this is week one. So I'm just solving the doubts. Is it okay for you guys? If you have any questions, you can just type. I'll just discuss tomorrow. Week two assignments. Live session will be tomorrow.
Okay, sir.
Yeah. So this question is like which of the following characterizes the ray nature of light? So you already know like this light exhibits fast like properties such as diffraction and interference, and that is due to the um, wave nature of light, not rays, not because of the ray nature of light. And the second option is like light travels in a straight line and casts a shadow of opaque object that it encounters. So here also that is incorrect because light is like we consider light to be a electromagnetic wave, and so okay, that is also sorry. This is like a straight line and cast a shadow of opaque objects. It means that it will necessary to having the characteristic of ray. And the third one is like light can exhibit a state of polarization such as linear or circular or elliptical. So this characteristic is not needed for ray nature. Yeah, maybe possible that polarization is it is exhibit, but it is not necessary to have while it is in ray form, with a ray nature. So this characteristic doesn't allow to this property doesn't allow the characteristic of ray nature. Okay. And the fourth option is light experience a change in direction when passing from one medium to another medium. As we know that refractive index changes the light direction and like path changes. So this also exhibits the ray property of the ray characteristic of light. So here you can clearly see that which characteristics can be useful for this. Okay, got it. So now question number two. The following phenomena 1 to 4 may be explained by considering light as. So here you can see that ray, waves, electromagnetic waves, and photons are given in a side, we can say one side, and another side it is given by polarization, photoelectric effects, diffraction, and total internal refraction. So rays exhibit like it will go in a straight path as we saw like in question number one itself. The ray is travels in a straight line and casts a shadow of like objects, distance, and also um, while it is passing through the medium, it's like one medium to another medium, it changes the um, path. So here you can see the ray plays a um role to give the property of total internal reflection. Okay, so the x1, the x1 will just directly related to total internal reflection here. Then y waves. So waves is directly related to diffraction. As you can see here, which option is yeah, and electromagnetic waves. And this is very much important for polarization. And the photons, obviously, it will give a photoelectric effect. So option number first only the correct. Okay. Now we'll move toward the question number three. So which of the following statement is false regarding the speed of light? Here you can see the speed of light depends on the medium it travels through. Um, yeah, it depends on that because it is directly proportional to like speed is speed light speed in medium v is equal to c by n. So n or you can say yeah n is reflection index. No, and not n. It's reflection index n. Yes. So here you can see this if it is higher denser mediums, then refractive index it will be high, and the velocity of light in that medium, particular medium, will be low. So here the option number is one is correct. Second option is telling that speed of light is faster in denser medium compared to less denser medium. It means like it's telling that uh, n will be high. Suppose n is high, and one suppose n is high, and for denser medium it will be high. So we can't be high. We should be less than C. But here this particular statement is saying that opposite one. So it is not possible. So this can't be so. So this is the options. We can say that it is false. The third option is the speed of light is faster in vacuum compared to other media. It's correct only because in vacuum it is the speed of light is c, and you can see the relation here. So it's correct. And the last one is speed of light is constant in vacuum. So yeah, it is also correct. It's like it is constant only. Okay, so question number four. Question is a beam of light traveling through beam of light traveling through air strikes a flat glass slab at an angle of 50 degree. The refractive index of the glass is 1.55. At what angle with respect to the normal does the rays exit through the glass? So this is quite simple questions. Here you can see that what they're asking. When you have a denser medium glass or a refraction index is high, which is and of glass is it is 1.55, and for air it is 1. When it's striking, light is striking with 50 degrees angle. So this will go like this in denser mediums. Okay. And what they're asking, at what angle with respect to the normal does the ray exit through the glass? It means like, okay, then injection is difference. Yeah. So here you can see what they're asking. They're asking particular that angle at which it will just exit through the glass like this. Okay. So for that, what will happen? We have to use the formula of Snell's law, that is n1 sin theta 1 is equal to n2 sin theta 2. Here you can keep our angle. There is incident angle is 50 degrees, so we will keep 50 degrees. And the glass refractive index, that is n2 GPS. And for air it is 1. This n1 is 1. And we can calculate the theta 2. So theta 2 we have to calculate. That's what theta is. Okay. Now, question number 5 and 6. Here, the common data for both questions is given. An optical fiber has numerical aperture Na of 0.45 and a 4 refraction index N1 of 1.46. And question number 5 is determine the cladding refractive index. So how we can determine this? It's quite simple. Uh, yes. Na square is equal to N1 square minus N2 square. Means higher refraction index medium minus the cladding refractive index. Okay. Suppose we have these two things. This is your cladding outside this thing. And inside this hole. So this one is given as a N1 1.46, and numerical aperture for this is given N1. N2 you have to find out. And numerical aperture also is given 0.45. Okay, so you can calculate like this for question number 5. Question number 6 is which of the following properties of an optical fiber are desirable when designing of an endoscopic applications. Endoscopic application, we need like very precise light. For that, we have to go for high numerical aperture. What is numerical aperture? The light, the property that allows the capture more light at a particular area, like better light gathering abilities. That is called high numerical apertures, and that should be needed for endoscopic application. large flading area, it is not any, it won't affect that much. So this is the like no need. In an endoscopic application, we don't have to bother about this flading area. Okay, and high refracting index in the core than in flaring. It means this is also refines the light. The high refracting index means confines the light into the high refracting index. I showed you previously just now. So this will be like lesser than N1 and this one is N2. So N1 should be greater than N2. If it is the separation between both refractive index is high, so we can say that this is also very desirable for this endoscopic application. So if it is higher receptor index in cladding than in core, then it won't worse because the lights should confine in the core's area, not in cladding area. Or if it is confining in cladding area, it can also scatter outside. So this is not appropriate for this. Yes. Okay. So question number 7 is in the question given below, there are two statements marked as assertion A and reason R1 and R2. Mark your answer as per the coded provided below. So assertion A is a double slit experiment is set up with a monochromatic light source. When the distance between the slit is decreased, the observed interference pattern on a screen becomes wider and the fringes become less distinct. Okay. So first reason is the large spectrum of light results in the reduction of the fringe contrast, and the second reason is the angular separation between the fringes is inversely proportional to the distance between the slits. Okay. So here the a monochromatic light source doesn't represent a large spectrum of light. So first of all, this large spectrum of light, this reason is incorrect here. And the second is the double slit interference experiment. The angular spectrum between adjacent fringes can be calculated using the formula. That is del theta. This formula. So when the distance between the slits d will decrease, the angular separation between fringes theta d theta will increase and can be derived from the formula mentioned above. This mentioned. Okay. So here you can see the angular separation between the fringes is inversely proportional to the distance between the slits. Yeah, it is correct. Okay. Like that you have to solve this question. Question number 7. Okay, so the option number two will be the correct answer. Now, question number eight. A glass film is used to disperse a beam of light consisting of two wavelengths, 650 nanometer and 520 nanometers. The refractive index of glass prism for these wavelengths are 1.52 and 1.56 respectively. The normal with respect to the entering and the exiting rays in the prism intersects at an angle of 165. Calculate angular dispersion produced by prism. So we have to find out the angular dispersion. So the formula is quite easy here. Like this section. It is equal to n2 minus 1 2. And how to find out this? N2 is given as this one. This is N1. And A we can find out like 180 degrees. That is 165. So 180 degrees. So it will be 180 minus 165. A will be this much. And if you put this values, then you will find out the theta value. Okay. Now this question number 9 and 10, those two questions having common data. So data is like it is saying that in Young's double slit experiment, a screen is placed 1 meter away from a double slit apparatus. The distance between the central fringe, bright fringe at the center, and the first bright fringe, first maximum, is measured to be 2 centimeters on the screen. So question number 9. If the wavelength of the incident light is 600 nanometers, the width of each slit, assuming that both of them are equal size, is in mm. So they are asking mm, that is, um, you have to find out like this. So this D is equal to m into capital D into lambda upon W. Where the value of lambda is given as 600 nanometers, and D is 1 meter, and M it is 1 because the first maximum, and W is 2 centimeters. So all the units should be converted into meter, the centimeter and nanometer, and then you put in this formula, then D value is this um, in that. Now the question number 10 is asking the angular position of the first bright fringe is in radians. So to find out the first bright fringes, we should know that that D is the formula is theta is equal to R sine lambda upon d. So both should be in meter or team unit lambda and d. Then we can find out this theta value, putting this values lambda and d, and that should be in radians. Awesome. In radians. Okay, so that's it for this one. Now, if you have okay, okay. So, could you please tell the need of electromagnetic optics? I mean, why we need electromagnetic optics in such presence of zero optics? Yeah, this is week two question, I think. I'll just go to it and tomorrow I'll discuss this. And, what does that mean, 29.6? For both of these? Okay. Question 5 is which which question you are talking about? Uh, Actually, you have to find yourself. I showed you the formulas, how to do that. And this videos will be available on YouTube, so you can follow that. All the these videos, assignments, the problems and the solving session. You can search my name also. Otherwise, through that NPTEL course name, you can search. So I think maybe tomorrow professor also will join to clear the doubts. If you have any doubts, then you can ask. Okay, question number 4. Yeah, question number 4. Okay, so here put this X. We'll keep everything here, values. We'll get what will the answer. Like here it will be sine inverse cos. And one is around 1.55. By n2 is 1. Sorry, let's take this confused. N1 is 1 and n2 is 1.55. And sin theta 1 is 50 degrees. Sin 50 you have to calculate before calculators. Then whatever value you are given, that is your answer. Is that right? I think you have to calculate again. Just calculate so you will get incorrect values. And this is you are close only, but um, let's try again. Okay. Regarding this, do you have any doubts regarding this one? Anybody? Okay, can you please tell which question you are asking about these two? So I'll just write down. Tomorrow we'll discuss. Uh, it was anything, only this question, whatever
Yes.
you ask, or something else. Do you have any other question?
No, sir.
Okay. Actually, today another another series is joined, routine joined. So okay, we'll just discuss tomorrow also. And after that, every Saturday we will having session classes. So that's it for today. So we'll wind up here. Okay. Yeah. So
Okay,
tomorrow,
sir.
please join whatever you have doubt. Every week we'll solve. If you have extra doubt, you can also text and like directly you can ask. 6 o'clock. Same time. Saturday. Every week. Saturday 6 o'clock. And mostly I will solve your doubts. If it is not possible through me, then I'll just let you after a week or like next week, or otherwise you can directly ask in my YouTube channel, like where I'll upload this. You can ask there. So I can solve out in that one. Better not. That is not an issue. So we'll wind up here.
Thank you, sir.
Yeah.
Thank you, sir.
Very nice.
Thank you.